Hello, welcome to Taxonomy Online Mathematics. The topic metrics is still going on. We are moving to solving simultaneous equation of a linear simultaneous equation involving three variables using the Cramer's method. So this will be the equations given to you. There are three equations, meaning there are three variables. Good. We need to first of all write matrix equation from that using the coefficient. So A, B, C are the coefficient. D, E, F. Next, G, H, I. This coefficient is supposed to multiply X, Y, Z, which are the variables we are asked to find. You see these variables that are repeating themselves. That will be equals to the other side, which is P, Q, R. So this is the matrix approach. We have our 3 by 3 matrix. We have our variable to be found. We have the other side. So we let our A, matrix A equals to, then we let X equals to the unknown variable. Then finally we let B equals to. So this is the matrix 3 by 3, 3 by 1, 3 by 1. This is the variable you're looking for. This and these are constant given to you in the equation, which will help you find the X, Y, Z. So if that is the case, it means that A, okay, let me leave it this way. Let me go straight with the Cramer's rule. We say that if I want to find the value of X, the value of X is going to be determinant of X over the coefficient determinant. If I'm looking for Y, determinant of Y over the coefficient determinant. And if you are looking for the Z, you still have determinant of that over coefficient determinant. Alright, how do we find? You see, this and this are the same, which are the one we already know. Determinant of 3 by 3, how we find it? We already know. Then what is the subscript X, Y, Z doing there? For this, if I'm looking for this A, X, it is still 3 by 3 matrix. I am going to replace the first column by B. When you replace the first column by B, it becomes P, Q, R, B, E, H, C, F, I. So you find determinant of this. We know determinant of this. We can go row or column by column. If I stand on this, this will multiply this determinant. This will multiply the determinant. So you replace the first column with your B. That is how you get this determinant. Then for that of X, Y is the second column. So the second column will be replaced by this. So A, D, G, second column P, Q, R. The third column C, F, I. When you find determinant of this, then you put it here, divided by the coefficient determinant. You get that of Y. Then that of Z is going to be replacing the last column by this. That will be A, B, P, D, E, Q, G, H, R. Find the determinant. Don't forget the determinant of A. I think I'm using determinant, so it should be a bar. You should put a bar behind, before, and behind. So it's just a bar indicating determinant. It is not a square bracket that I'm using in the beginning. So for A, it is just the actual determinant, A, B, C, D. The determinant of this. When you put them together, then you'll be able to find X, Y, Z easily without any stress. I believe that concept is clear. Let's take a question and solve it using the approach and see what we can get. So these are the three equations we are asked to find. So first of all, let's take our matrix equation, picking the coefficient of this will be 1, minus 2, 2, minus 2, 1, 2, 2, 2, 1. And that is supposed to multiply our X, Y, what? Z. And that will give us our answer as what? 7, 1, what? 2. So where we have this being our A with the matrix, this being the X, this being the B. So if I want to find X, I need to find the value of this divided by what? This. But how will I find this? We know I need to know this, whereby the first column will be replaced by what? This. So for my determinant of X, I first of all need to replace first column 1, 2, negative 2, 1, 2, 2, 1. The determinant of this. I need to find the determinant. I would like to go on the second row. So plus, minus, plus. Minus, plus, minus. That's what I'm going to use. So I'll start with this. So first of all, minus 1 into bracket. The row is going. The column is going. I'm left with 1, 2, 1, 2. So minus 2 minus 4. That is my the first one. It should be plus because this is plus. So plus 1, which is this, covering everything here, everything here. I'll be left with this and this. So 7 minus what? 4. It should be minus. So minus that 2 in the bracket, taking every row and column. So I left with this. 14 minus minus 4. So our A determinant is going to be, inside this, you'll be having minus 6 times this, so plus 6. This will give you 3. That's it, plus 3. This will give you plus. So in that plus will give us 18. 18 times this, negative 36. If you add this here, you are going to have minus 30. So I have minus 27 for this. Okay. So in order to find all the answers, let me find AY, which is going to be replacing the second column with this. So I have 1 minus 2, 2. Second column will be replaced with this. 7, 1, 2. Then the third column will come. Determinant is going to be, I will use, okay, the first row. Plus, minus, plus. So this is going to be plus 1. Covering everything, I'll be left with this. So 1 minus 4 minus 7. Everything down, top is go. Minus 2 minus 4. This is plus. So 2. if everything is gone, you'll be left with this. So minus 4 minus what? 2. What will I get? This will give me minus 3. This will be minus 6 times this plus 42. This will be minus 6 times this minus 12. So inside this I have 30, right? 30 minus this, that will be 27 for the determinant of AY. Let me take the top. We are replacing the last column with this. So 1 minus 2, 2. Minus 2, 1, 2. This will come 7, 1, 2. It's a bar. So I'll go the first column plus, minus, plus. So 1 plus 1 into bracket. Every row is going, every column. 2 minus what? 2. This will be minus. So minus, minus, plus 2. This is going. The top is going. You're left with this. Minus 4 minus 2. Then we have plus 7 into bracket. Every column, every row. Minus 4 minus 2. So this is going to be 0. This is going to be 6, minus 6. So minus 12. This will be minus 6. Is that not it? So minus 42. And that will give us minus 54. So we know A, X, Y, Z. What of the coefficient matrix itself? So let's take that. I think the coefficient matrix is so now we need to find the matrix. We have plus, minus, plus. So what do we do? Plus 1 into bracket. If you pick everything away, this is going to be 1 minus 4. Minus, minus, so plus 2. This is going. The top is going. I left with 1. So minus 2 minus what? 4. Plus 2. Everything is going. The top is going. Minus 4. Then minus 2. This will give you minus 3. Minus 6. So minus 12. Minus 6. Minus 12. 24. Minus 27. So we have this. We have, from the calculation we did, we have the x to be this. We have the y to be this. So now to find the value of x, it will be ax over a. And as is what? Minus 27 over a minus 27. So x is going to be 1. We have this to be 27. This negative 27. So I have what? Minus 1. Z is going to be the value of that is minus 54. I believe this will go here 2 times. So we have what? 2. Therefore, x is 1, y is minus 1, and what? z equals to 2 as our final answer. So using the Cramer's rule to find a simultaneous equation involving 3 variables is possible. It's possible following the step one by one. The video might be long, but please take your time and follow step by step. You should be able to do it. If you are new, consider subscribing to the channel, like, share, and comment. See you in the next episode as we may take linear transformation under matrix.